Hi everyone, welcome to Slope Day 2. Hopefully you enjoyed yesterday's practice problems and lesson instruction. Today we're going to continue learning about the characteristics of slope. So if you remember a couple units ago, we worked on proportional relationships. So I'd like to take you back through looking at a relationship that's proportional. So here we have Mikey's bike ride. Mikey's going on a bike ride and he wants to determine his speed. His speed remains constant for his entire trip. Help Mikey by filling in equivalent minutes and miles into the table and then graphing the situation. So if you look, Mikey has already recorded that in 20 minutes, he goes 6 miles, and in 40 minutes, he goes 12 miles. Based off of this information and the fact that he said his speed remains constant, I can come up with other equivalent minutes and distances to fill in this table. So if I want to split his 20 minutes in half, I would have 10 minutes, which would then result in half of 6 minutes, which would be 3 minutes. Likewise, I can also get larger, and I can keep counting up. So I noticed they did 20, 40. So I said, oh, I might as well find 60 minutes. So I look for some relationship of how I can get from one of the minutes I already know to 60 minutes. So I can easily take 20 minutes and multiply it by 3 to get to 60. And therefore 6 miles times 3 would mean I'm now at 18 miles. I continue this pattern. 80 minutes. Well, I know that 80 is just 40 doubled. So 12 doubled is 24. And I'd keep going. 100 minutes. Well, I know to go from 10 minutes to 100 minutes, I multiply by 10. So to go from 3 minutes down below, I also need to multiply by 10. So I would be at 30. And now I could keep going with higher and higher numbers, but when I look at my graph, I see that the time ends at 100. The one thing we don't have in this table is how far Mickey goes if he travels 0 minutes. Well, considering he's on a bike, if 0 minutes goes by, he hasn't traveled anywhere. So we've got 0, 0. So the next thing we need to do is graph the points of Mickey's bike ride onto the graph. So I go ahead and graph 0, 0. Now I'm not going to graph every single one of these points, but I'm going to graph a point at each interval that's on the x-axis. So I would graph a point at 20, 6. I would graph another point at 40, 12, 60, 18, 80, 24, and 130. And when you draw a line through these points, you see that it's a nice straight line starting at the origin. So if you recall, these were the two determining factors on whether or not a relationship was proportional. All the points had to fall on the line, and the line had to start at 0, 0. Therefore, this is a proportional relationship. Okay, so let's see if we can answer the question. What is Mikey's speed? Well, speed is just miles per hour. They're essentially asking us to find the constant of proportionality. Well, if I look at this graph and/or table, I know that an hour is 60 minutes. So in 60 minutes, Mikey is going 18 miles. Therefore, his speed is 18 miles per hour. All right, so let's talk about what this constant of proportionality means in this unit we're calling slope. How are the two related? When a constant of proportionality is used to find infinitely many equivalent ratios, like we just did in the table, and those ratios are graphed, you should see that all the points fall on the same line, which we just saw in Mickey's bike problem. These equivalent ratios form a line that has a specific steepness based off of the constant of proportionality, and we call how steep a line is the line's slope. Remember, slope is a measure of how steep a line is. That steepness can be measured using equivalent ratios. When we set up the ratio, we are always comparing the vertical change, which is the change on the y-axis going up and down, to the horizontal change, which is the change on the x-axis going from left to right. You may hear the vertical change referred to as the rise because you're going up and down, and the horizontal change referred to as the run, running left or right. Definitely feel free to take notes off of this slide. There's a lot of important information here, and definitely some new vocabulary that you may have not heard before. So go back, reference this slide as much as you want. All right, let's look at Mikey's bike problem again, bringing it back. So here's the graph, and here's what we came up with for his speed, 18 miles every hour. So what's the big idea here? The big idea is that if the constant of proportionality is 18, then the slope of the line that represents Mikey's bike ride is 18. This line's steepness is 18. Okay, here's another example. Here you're given a graph on water usage. Along the x-axis, they have graphed time that has passed by in minutes, and along the y-axis, they have graphed the gallons of water that have been used. Remember, if you can find the constant of proportionality, you can find the slope. So take a look at the points that are already graphed. You can pick any point you want. I like to pick a point that I'm sure of. I can see that there's a point at 2,10. So this point tells me that 10 gallons of water are used after 2 minutes. In other words, the rate at which water is being used is 10 gallons every 2 minutes. Well, if you recall how we found the constant of proportionality back in a previous unit, you're going to use the same method to find the slope now. Reduce this 10 gallons every 2 minutes to 5 gallons every 1 minute. You have the constant of proportionality, but remember, the constant of proportionality is just the slope. So the slope of this line is 5. All right, good job. I hope you followed along with those notes. Feel free to rewind, go back over any example that you need to. At this time, you have the ability to click on the link to the right and access your exit slip. Great job. See you again soon.